Namaskar and welcome to StudyIQ. I am your friend Rahul Saigaonker. The agenda for today's discussion is connected to space domain. We are going to discuss about ISRO's Aditya L1 mission, which is going to be launched very soon. This discussion is going to be a very good template for all the UPSC civil services aspirants to understand how to prepare any current affairs topic in totality. Let me put in a cautionary note. This discussion is going to be lengthy. It's going to be factual one, but very important one, where we can anticipate many topics from which MCQs can be created. We are going to discuss about what is Aditya L1 mission, what is L1 in this mission, what are Lagrange points, and then we are going to discuss about this current affairs news. Why are we discussing about Aditya L1? Because recently a Pune-based institute has delivered one of the payloads of Aditya L1 spacecraft, which is called SUIT, S-U-I-T, Solar Ultraviolet Imaging Telescope. So we'll talk about all these topics. So get ready to be bombarded with information. Let us begin. But before all that, if you're preparing for UPSC Civil Service Examination, then StudyIQ is offering its flagship program, Prelims to Interview program. It has already begun from 19th of June. The orientation class is done. Just the first class is done. You can still enroll for it. The admission is closing on 30th June. If you have already done it, I'll see you in the class. If you have not done it, then you are losing out on golden opportunity to prepare for UPSC Civil Service Examination in a comprehensive and integrated way. Because StudyIQ will be hand-holding you through your prelims, through mains, through interview. This entire program has been designed at a very affordable price. To get maximum discount, do use my code RAHULLIVE, which is applicable on the website www.studyiq.com or the app. You can simply look for the App Store on your Android phone. Then you can download the StudyIQ app. There also, you can use the code whenever you check out. So do it soon. I'll see you in the class. Right, let's begin. As I told you, the news is basically this, that a Pune-based institution, Inter-University Center for Astronomy and Astrophysics, it has delivered one of the payloads of Aditya L1 spacecraft, which is called as SUIT, S-U-I-T, Solar Ultraviolet Imaging Telescope. They have delivered it to ISRO. And you do know that ISRO is going to launch Aditya L1 mission very soon, although it was supposed to be launched last year in 2022, but because of delays, COVID-related delays, other delays, the date has been given as mid-2023. We're already in mid-2023, so we can expect the date to be somewhere around July or August. Very soon, we will get some sort of communique from ISRO about Aditya L1 mission. So in coming months, look out for this current affairs news. Let's talk about this. What is this Aditya L1 mission and what is this payload, right? First things first, Aditya L1 mission. By name itself, Aditya, meaning this is one of its kind of a mission by ISRO where we are going to launch a spacecraft along with the payloads to study the sun. Right? And L1 is a point around which we are going to launch this spacecraft, which is going to revolve around the L1 point in a halo orbit. This L1 point is about 1.5 million kilometers away from Earth. Why are we launching it at L1? Because there is an advantage. I want to observe the sun. I want to do research on sun. I know that sun has different layers. There is photosphere, chromosphere, corona. I want to do research on that. And for that, I would like to launch this spacecraft on the L1 point where I can continuously observe it. One of the unique things about this is that this spacecraft, when it is launched at this point L1, there would be no occultation or eclipse. It would be viewing sun continuously, right? Apart from that, it is going to give great information about solar phenomena. Apart from that, we are also going to study a lot of other aspects connected to space weather, right? Because we do know that in recent times we have seen news about solar flares, solar winds, the geomagnetic storms. So we will be studying different particles that are ejected from the sun, and we'll study those because it is very important for us, because we want ourselves to be safeguarded from ultraviolet radiation. For that, there is ozone layer, and we are doing a lot to protect that ozone layer also. So this mission is going to study sun. It is going to study sun's corona, chromosphere, photosphere. So it is going to study in different ranges, in the visible range, infrared range, in the ultraviolet range. And the SUIT, this telescope, it is going to focus on the ultraviolet imaging. All right. Now, This is going to be second mission of astronomy. Please remember, India till now has launched two missions, or I would say it is going to launch the second mission very soon. The first mission dedicatedly for astronomy was AstroSat, which was launched way back in 2015. It's defunct as of now, but dedicated for a celestial body, that is sun, to study sun. This is our first mission, but overall second mission for space-based astronomy. Please remember another very important factoid, that Aditya L1, whenever ISRO is going to launch it, it is going to launch it on the PSLV XL launcher, right? So this can become a pitfall for you from MCQ perspective. It's not GSLV, it's not GSLV Mark II or Mark III. It is PSLV XL launcher, again from Sriharikota itself. So as I told you, what is its mandate? ISRO tells that the major objectives of Aditya L1, they include to study solar upper atmospheric phenomena, right? To study the chromosphere, to study the photosphere. As I told you, in recent times, we have seen solar flares, solar winds. You must have heard about the news of smiling sun, right? Sunspots, right? That is sun's magnetic field. All these things would be studied through Aditya L1 mission. That means we are also going to focus on particle dynamics of the sun. Sun releases many solar particles. Many of those particles reach Earth in the upper atmosphere. We know about the concept of auroras, aurora australis, aurora borealis. So we'll be studying the solar particles, the sun's different layers, chromosphere, photosphere, corona, etc. So these are the major science-based objectives of Aditya L1. So this was about the mission. We'll talk about this further at the end of discussion when we talk about different payloads as well. But this is Aditya L1, very soon to be launched. Now, the next question is, what is this L1? So what is this L1? I want to understand, because normally whenever we launch a satellite, that satellite is going to catch the orbit of Earth. It can be low Earth orbit, it can be medium Earth orbit, it can be the geo orbit, right? Or say if I launch it to some other planet, we saw with the Mangalyaan mission, MOM, right? Mars Orbiter mission. It caught the orbit of the Mars, right? So what is this L1? What exactly are we doing? See, L1 is one of the Lagrange points. Lagrange points were calculated and they were defined by a French physicist, French mathematician also, Louis Lagrange. He gave that, he basically enunciated that there are certain positions in space where objects, when they are sent, they tend to stay put. That means that there is no need to move. They will move along with the gravity, along with the rotation of Earth itself. These are called Lagrange points. So at Lagrange points, the gravitational pull of two large bodies. Now, in this case, we are talking about two large bodies, Sun and Earth. You do know that every body attracts another body through a gravitational force. It is quite considerable for the celestial bodies. The higher the mass, the higher the gravitational force, that we know. So Sun and Earth, they are attracting each other with some sort of gravitational pull. So the Lagrange points are those points at which the gravitational pull of two large masses, in this case Sun and Earth, they will be precisely equal the centripetal force required for small object to move along that point. Meaning, if I send a spacecraft, if I send a satellite at this particular point, it tends to stay put. But that is the ideal scenario. Please try to understand, that is the ideal scenario. So Louis Lagrange gave 5 Lagrange points for any celestial system. Now, this is the celestial system, Sun and Earth. Please remember, for any system, there can be 5 Lagrange points. And when we talk about Sun and Earth system, 3 Lagrange points are seen on the line connecting these two bodies. This is Sun, this is Earth, and if you draw a horizontal line connecting Sun and Earth, the point L3 will come here, point L1 will come in the middle of these two bodies. So L1 point is somewhere between Earth and Sun. So from Earth, this is at a distance of 1.5 million kilometers. L2 point is beyond Earth. This is again 1.5 million kilometers away. L4 and L5 are the points which can be created by simply creating an equilateral triangle like this. So this is point L4 and this is point L5. All right. As I told you, Lagrange points can be drawn or can be calculated for any two celestial bodies. For example, I can draw Lagrange points for Sun Jupiter system. I can draw Lagrange points for Sun Mars system. I can even draw Lagrange points for Earth and Moon system as well, because there is gravitational pull between these two bodies, and there are certain points at which this gravitational pull is balanced. So if I send some object there, it appears as if it is stationary. Clear? These are Lagrange points. And remember, we are sending Aditya L1 at the L1 point. That means it is going to travel from Earth and it is going to travel at this L1 point. Now the question is, so why L1 point? Why not some other point? Let's try to understand more about these points. As I told you, there are 5 Lagrange points, and out of these 5, 3 Lagrange points are actually unstable. Unstable. I'm repeating this. 3 Lagrange points are unstable. Now, which Lagrange points are unstable? The ones on these horizontal lines. So L3, L1 and L2. These 3 are unstable. Let me write it again. They are unstable. Again, this is a pitfall when I create a MCQ. You must be thinking, sir, if these points are unstable, then why are we sending any spacecraft or any project here? Why not send it to stable points? Stable points are L4 and L5. See, L4 and L5 are more stable points. But there is a catch here. Right? Why we are sending it to L1, we'll understand. Because when we talk about L4, L5, since these are stable points, that means any other celestial body would tend to reach there itself. In fact, the points L4 and L5 are such points where you will see many Trojan asteroids which are orbiting in halo orbits around L4 and L5. And if there are so many Trojan asteroids here, why would I send a spacecraft or something spending crores of rupees, right? It makes sense, isn't it? Now, the next question is, sir, why L1, L2, L3? Why are they unstable, right? Because as you can see, in this particular system, as the Earth is revolving, the point will also revolve. That means if something is at this point, it is going to be balanced and it is going to revolve. Of course, it is going to revolve. But please remember, a lot of fuel saving can occur if we send something at this particular point. Continuous observation of space, astronomy based studies, observation of sun can happen. So at point L1, we have already sent, not India, but NASA has already sent SOHO. It's already home to SOHO, the Solar and Heliospheric Observatory satellite. At L1 point, there is already SOHO. And L2 point, there are multiple equipments. Earlier, L2 point was home to the WMAP spacecraft, right? Wilkinson Microwave Anisotropic Probe was sent there. It has become defunct. But L2 point is the home to James Webb Telescope, to Planck Telescope. It is also the home of Gaia probe by European Space Agency. The next question is, sir, you told these are unstable points. Then what do we do exactly? See, at these points, what we need, meaning at this point, if I send a spacecraft, now if I send Aditya, say this is Aditya, so Aditya will be simply orbiting in very slow speeds around this particular point, and that too in a halo orbit. That means I have to do regular course correction and altitude correction so that it will remain in a balanced position. And NASA says that at L2 point, correction is needed every 23 days. Point L3 is rather useless because it is behind the sun. Till now, we have not sent anything here. So technically, there is nothing sent to L3 point. Sending to L4 and L5, it does not make sense because it is home to huge Trojan asteroids. There are many examples: Agamemnon, Achilles, Hector. You must be thinking this is Troy movie. No, these are the names of some of the biggest Trojan asteroids which are in the L4 and L5 region. So the next question is, sir, what do I do? I still want to understand that there is already SOHO. You told there is already SOHO here. So I am sending my Aditya L1 also here. So how are things going to work? Let me explain what is going to happen. See, when Aditya L1 will be launched very soon, probably next month, July, August. So it is going to be launched. It is going to take turns around the Earth, and then it is going to leave Earth orbit. It is going to travel about 1.5 million kilometers. Then it is going to go into cruise phase and catch an orbit around L1. This is the point L1. This is the point L1. Now, it is going to orbit around L1 in some sort of a halo orbit, not exactly a circular orbit, but please remember there is already SOHO here. So SOHO would be in another orbit somewhere around L1. Now our Aditya would be again around L1 in another orbit. So it means it is not going to revolve around Earth or Sun, it is going to revolve around this particular point. And these are the halo orbits. You can see here for L1, L2, L3, L4 and L5, the halo orbits, they are in shape something like this. As I told you, there are so many asteroids. The asteroids tend to orbit around L4 and L5, something like this. All right. Right. So these are Lagrange points. I hope it's clear. I can create a lot of MCQs around Lagrange points as well. Now let's go back to the current affairs news. As I told you, why are we discussing this at all? Because recently Pune-based institute, the Inter-University for Astronomy and Astrophysics, they have delivered SUIT. SUIT is Solar Ultraviolet Imaging Telescope. This has been designed for UV imaging. It is going to study the UV emission and capture the images of sun to study it. It is going to study the dynamic and complex processes going around sun. As I told you, sun is in different layers. Sun has a core where the real thermonuclear fusion reaction is going on. The temperature is somewhere around millions of degrees. But photosphere is something which is around 4,500 to 6,000 degrees Celsius. But as you go out of photosphere, please remember, photosphere is at 6,000 degrees Celsius, then chromosphere, which is at a higher temperature, then corona, which is still higher. Please remember this phenomena also. Photosphere is at a temperature of 600 degrees Celsius, 600 Kelvin approximately, no issues. This is 6,000. Chromosphere is higher than that. Corona is much higher than that. Many times aspirants, they think it's the reverse order. No, right? So we are going to study a lot of things. Now this SUIT, this is the CAD diagram of this Solar Ultraviolet Imaging Telescope. This SUIT, it basically uses Ritchey-Cherian configuration. Now this is an optical configuration where different lens setups are done so that I get a widened image of any particular object that I'm viewing. So this is going to image sun in around the wavelength of 200 to 400 nanometers, which is the ultraviolet range. Through this, ISRO is going to record images in the wavelength range, which is very crucial to understand ultraviolet radiation about UVA, UVB, which are very important for us. Because if ultraviolet radiation reaches Earth, then it can lead to cancer, it can lead to skin cancer, etc. Apart from that, this research is also going to address to the questions of higher temperatures above the surface. As I told you, it's a strange phenomena. 600 degrees Celsius here inside in the photosphere, and it is higher towards chromosphere and corona. Why? We'll try to understand that. We'll also do a lot of magnetic based studies, but not through SUIT, but through other payloads. And please remember, SUIT is expected to have a lifetime of approximately 5 years. For 5 years, it is going to send us data. This is the CAD model of that, right? So this is going to be sent along with Aditya L1 mission. So next question. Sir, you said Aditya L1 is a spacecraft. We are going to send it to L1 point. So what are the payloads? Is it just one payload? No. These are the payloads that are going to go with Aditya L1. One of them is SUIT, but there are many other payloads like Swiss, STEPS, Helios, VELC, Papa, right? What are these? Let's try to understand. See, totally there are going to be 7 payloads. There are going to be 7 payloads, and these are the 7 payloads. Out of these 7 payloads, 4 are remote sensing payloads and 3 are in situ payloads. Now, these 4 remote sensing payloads, they are going to continuously image the sun in visible range, in X-ray range, in X-rays through extrospectrometer and through this SUIT. So 4 of these payloads, they will be getting a very good vantage point L1, from which they are going to continuously observe the sun. Apart from that, there are 3 more payloads called as ASPEX, Papa, and Advanced Triaxial High Resolution Digital Magnetometer to study the magnetic fields. And these are going to assess the solar particles. There is a solar particle analyzer, right? There is solar wind particle analyzer. So these will be analyzing the particles that come out of sun. And please remember, SUIT has been delivered by Inter-University for Astronomy and Astrophysics in Pune. But the other payloads are delivered through different institutions. For example, VELC is being developed by Indian Institute of Astrophysics, which is in Bengaluru, right? Apart from that, the APEX, it is being delivered by Physical Research Laboratory, Papa, the analyzer. by Space Physics Laboratory, Vikram Sarabhai Space Institution. This is a list of that. And all these institutions, they are working in collaboration with ISRO. All right. So please remember, Aditya L1 mission, it is going to be launched very soon. It is going to carry 7 payloads with it. 4 payloads which are going to focus on remote sensing. 3 are in situ payloads which are going to analyze the different particles that are released from the sun. Right? So are you flustered because of too much of data? I gave you a cautionary note. This is going to be a lengthy discussion and you will be bombarded with data. I hope that you have collected all these things. MCQs can be created on this, and do keep a track of Aditya L1. We will also be doing it whenever it's launched. We'll discuss that again. Right? That's the end of today's interaction. Again, if you have liked this discussion, you can always follow me on this particular ID @ Rahul Sai 222. Thank you for watching this video. Jai Hind.